This video is going to look at how to do structural design in VHDL using components, and we'll do this by working through practice problem 5.13H from the textbook. And if you look at this problem, what it says is for this truth table right here, 3-input truth table, we are going to design it with structural VHDL, which means we're going to instantiate lower level components in order to accomplish this. And so what the problem is getting to is that you're going to basically design this by hand, maybe canonical sum of products or whatever, and then for any basic gates you need, you're going to create the lower level basic gate. So if you need an inverter, you're going to have to, instead of using not A, you have to actually create an inverter file, and you'll call it INV1, and then you'll instantiate that in your higher level system. So if you need a 4-input AND gate, you got to go make it. If you need an OR gate, you got to go make it. Now the basic gates can be made, using, once you get down to the lowest level, you have to use the logical operators. But the idea is that your system is going to not have any, operators in it other than just components and connections. Okay, so the first step of this is we got to design this, and let's just do a canonical one so we don't have to mess around with anything. So here's the truth table. 1100, 1101, and we go ahead and say let's just do our min terms. So there's our min terms, and we put that into a logic expression. So there's our logic expression right there. And then let me close my email here. Then we are going to draw the logic diagram, which is right here. And let's take a look at this. So here is what we need to build. And again, this is just to show you how to use structural design and how to instantiate components. You wouldn't do this type of design using low-level gates like this. But let's take a look at this. So we're going to build this large expression. We're going to use inverters, 3 inverters up front in order to create the complements of the input variables. We will use, since this is a canonical sum of products, we're going to have 3-input AND gates. And then since we have 5 rows that correspond to an output of 1, we need a 5-input OR gate. So we need to go build an inverter, we need to build a 3-input AND gate, and we need to build a 5-input OR gate. So let's see. So what we can do is let's just put down the names of what we're going to basically design. We need to make inv1.vhd, so that's going to be one file that we need to make. And then we're going to make an and3.vhd. This naming convention is very common. In VHDL, you put the logic operation followed by the number of inputs, and then we'll do an OR 5. And what you'll actually find is that a lot of the libraries and tools actually have these basic gates for you, but we don't have them, so we're going to build them ourselves. All right, so we're going to build these 3 lower level components, and then we'll instantiate them in our system, which is called System G, just like before. And this is where we'll do all our design work. And then there's going to be a System G test bench, which will stimulate this just like before, and we should get the right functionality for this truth table. So here we go. So what I'm going to do is let's start by building making our folder. So I go out into here. Actually, I'm sorry, that's System H. We're doing the truth table for H, so this is going to be System H. So we need to go get the H test bench. All right, off we go. So I go to my folder here, and I make a new folder called System H, and then I go out to Desire to Learn, and I will be able to find this under Practice Problems, and there is the System H test bench, and so I'm going to go ahead and download that and bring it on over. Okay, so now I'm ready to begin. So let's go into ModelSim, and I'll leave my truth table of what we're trying to accomplish right there. And I go into ModelSim, and I'm going to do File, New, Project, and let's just call it System H Project. Make sure to browse into the folder that you just created. So I'm going to go down to System H, okay, leave the work library the same, and I'm off. Okay, it creates the project. I'm going to add an existing file, and there it is, System H, test bench. I say okay, and now let's rapidly create some files. Okay, so I need a System H, so I'm going to do a create new file. I'm going to call it systemh.vhd. I say okay. It created it for me, it's blank. But I also am going to need to create 3 other files. I need to create inv1, so let's do inv1.vhd. Oh, the path name specified, huh? Okay, hold on. Okay, I had to give the path name there, so let me, I'll do the next one. So create new one. So you got to browse to it. It wants you to click on that, System H, and then let's do the and3.vhd. Okay, now it's working. It just needed me to give that path name, so you got to hit browse each time. That's fine. Then let's see, I need an or5.vhd. Okay, so there's all the files that I'm going to need. System H is what will be called by the test bench, and these 3 basic gates will be created by me, or by us, and instantiate them in System H. So let's start off. inv1, and let's make this really quick. We're going to make an inverter. Entity inv1 is port. We need an input. Well, I don't know. Let's call it A. Its mode is in. Type is bit. And in an output, let's call it F. Type or mode out. Type bit. Boom. And end entity. And we're done. Architecture. inv1 arc of inv1 is, and I begin, and I say F gets assigned, not A, done, end architecture, done. Alright, so I save that up, and let's just see if it compile selected. Oh, I have an error. Look at this. Well, let's go see what the error is. Syntax error. Line 6. Oh, I misspelled architecture. No worries. Architecture. We got it. Alright, life is good. Let's save that up. Compile it. Money. Alright, now let's do our and3. I double click on that. You can do this with copy and paste too, but I'll just write it out just so you can see the process. Entity and3 is port. Okay, I need 3 inputs. Let's call it A, B, and C. Mode is in, type is bit, and it's got 1 output. Let's just call it F for no reason. And out, bit, boom, done. End, entity, and there we have it. Okay, architecture. Architecture turns red. I'm going to say and3 arc of and3 is. I just begin it on up, and I say F gets assigned A and B and C and architecture done. Alright, let's save that and compile it. Compile selected. Boom, got it. Alright, now or5. I say entity or5 is port. Here we go. I need 5 inputs. A, B, C, D, E. 1, 2, 3, 4, 5. Mode in type bit. And then the output, let's call it F. And we'll give it a mode of out type bit. There we go. And I think we're done there. So let's end entity and architecture. Architecture. We'll call it or5 underscore arc of the entity or5 is. And I begin. And I say F gets assigned. Let's see. A or B or C or D or E. Done. Alright. Let's see there. And end architecture. Architecture. Done. Let's compile this up. Compile selected. Got it. Okay. Now these compiled and they look like they work, but if you have a functional error in here, like you actually typed NOR instead of OR, you wouldn't see that until you actually get to the simulation. Okay, system H. Let's begin. I say system. No, I don't. I say entity. System H is port. Now this one we are creating, remember now what we're creating at this level. We're creating system H.VHD. So we're creating this system. And the ports for this are A, B, C, and they're they're mode in type bit. And the output, we'll call it F, and we will give it a mode of out, type bit, boom, end, entity, and that's it. Okay, ready? Now let's describe some functionality with an architecture. We'll call it system H arc of the entity system H is. Alright, now we're ready here. So I'm going to begin down here, but I need to declare my signals and I need to declare my components. So the question first is, which signals are we going to need? Alright, so if I go back and I look at my actual schematic here, I'm going to drop down 3 inverters, and I need signal names on the outputs. The inputs I can just use my port name. So I have port names A, B, and C, so I'm good there. And then my signal names, I'm going to need some signal names. So let's call it AN, BN, and CN. So I need those signals for sure. So let's go signal, and I'm going to do, okay, I can never remember the syntax. I'm going to go look at something. It goes signal name :bit. Okay, I just look at this existing file of the test bench, and that reminds me. So I'm going to say AN, BN, CN, type bit, done. Alright, then those are going to come out of the inverters. They'll be used in the inputs to our 3 input AND gates, and we'll also use the port names. So I have the red right here is going to be, red is a signal, a user-defined signal that we just declared, and then the black ones will be the port names. But we need a signal name for each of the outputs of the AND gates. So again, let's just call them kind of this min-term naming convention. So we have M0, M1, M4, M5, and M6. Is that right? Let's see, M0, M1, and then 2, 3, rows 2 and 3 don't have one. Then we have 4 and 5, that's good. Then we have 6, then we have 7. Let's call this M7. Much better. So we need those signals. So let's pop those in here. So let's go signal M0, M1, M4, M5, M7, type bit. Look at that, BT is a keyword, bit. Alright, so we come over to here, and we got our signals. Now we need to declare our components. How do you declare a component? You go keyword component, then you give it the name of the component, INV1, and then you declare, or you put down the ports. And this port, the port definition here has to match the lower level entity exactly. So there's no sense typing it in. Go ahead and just open up your inverter and copy this. So I copy that, and let's see, where is it? That's the test bench. I paste it, okay, back into system H, boom, and clean it up, make it look readable, and that's it. And then you go end component. That's it. Okay, I have declared that I'm going to use this lower level thing called INB. Alright, let's declare also that I need an AND 3, and let's go get the port definition for that one. So I just copy it right out of here, come back into this, and I go boom, and then I clean it up a little, and then I go end component. I've just declared that I will be using AND 3, and then I do a component or 5, and let's go get the port definition for that one. So I come up here and I copy that directly out of the entity for the OR 5, and clean it up just a little bit, and I end component, and now I'm ready to begin. So now I can wire up all this stuff. I've declared that I'm going to use these these three levels down here, or this inverter 1 and 3 and OR 5. And now I'm going to come down here and I am going to describe my functionality, but I'm going to do it structurally, which means all I'm going to do is wire up these lower level components. So let's begin. Let's do the stage of knots. So I'm going to call, I need to give these descriptive names. So usually you call something a U1 if it's a device like a chip. So we'll just say U1 and then INB1 and then port map, and then we list how we're going to connect the ports up. So I'm going to say, let's see, A is going to be connected. A is the port on the inverter, and I'm going to connect that up to A of my system. So they happen to be the name of the same thing. That's fine. F is going to be connected to AN, and that's it. Now A is the lower level port, F is the lower level port, A is the R level, so this is the port coming into system H, and then AN is the signal that I've declared. Now at this point I'm going to compile, because I've written a lot of VHDL here, and I want to make sure I don't have a typo. So I'm going to go end architecture. Okay, now it should compile. Maybe I'll get some warnings because I have floating signals, but compile selected. Okay, so okay, good. It compiled correctly, and that means my signals are fine, my components are fine, everything's fine. Now I can start doing some copying and pasting. Let's get those first three inverters in there. So U2, U3, and that is now how I do my first three stages of inverter. My first stage of three inverters, and I've now created AN, BN, and CN. All right. And so I can go and put a comment here and say not. Alright, now let's do the product terms. So I need U4, and this is going to be my 3-input AND gate. And then I'm a port map, and I'm using explicit port mapping. Now these ones have ports called A connected to something, B connected to something, C connected to something. So let's take a look at the first one. I need to wire up AN, BN, and CN for this first product term. So I say AN is my signal name at this level, and then the port B of my AND gate is connected to BN, and finally C of the component is connected to CN. So those are my three inputs, and then the output of that AND gate is connected to this signal I created called M0, and that is it. Now let's see, did I do that correctly? I'm going to compile this and make sure. So compile selected. Okay, my syntax is correct. I got A is connected to AN, B is connected to BN, C is connected to CN, and F is there. Okay, good. I need 5 of these. So let's go ahead and just slap them down. Okay, so I'll go ahead and name it U5, 6, 7, 8. And let's now go in and wire up them correctly. So the second AND gate is AN and BN and then C. My third AND gate is A, B not C. So I got A, B not C not. Is that what I said? Okay, the fourth one is A, B, N, C. So A, B, N, C. And then the final one is just A, B, C. So my inputs look good. So let's check the inputs again. So we got AN, BN, CN, AN, BN, CN. Then we got AN, BN, C, that's good. And then we got A, BN, CN, good. And then we got A, BN, C, good. And then we got A, B, C. Okay. The outputs, let's get those connections going. So we got M0, M1, M4, M5, and M7. Okay, so U4, 5, 6, 7, 8. Good, good, good. So let's compile that, make sure we didn't mess that up. Compile selected. Good, we're good. The final stage, so these are my ANDs, or my product terms. The last one is simply the OR gate. So I got an OR 5, and I port map it up, and I have 5 inputs. So A is going to be connected to M0, B is going to be connected to, I'm going to put that on the clipboard, B is connected to, what, M1, and then C is connected to M4, and then D is connected to M5, and then E, the final input, is connected to M7, and then the output of it is connected to the output of our system H. Okay, that is it. So let's compile that up, make sure that I hooked that up right. And if I mess this up, I'll definitely see it in the simulation. Let's check this. M0, M1, M4, M5, M7. So I've got all those, they're all together, and architecture as we're ready to simulate. So I'm going to compile my test bench, make sure everything's cool. We're ready. Let's go into my library. I expand work. I load. Now look at all the things that have been compiled now. We got more things. We load the simulation though, always by double-clicking on the test bench. Okay. Let's see. So for some reason this thing is now at the bottom. Let's do that. Okay, so I'm ready. Let's do it. I'm going to come over here, right-click, add to, wave, signals in region. And now I got my 3 inputs of system H and the output. I go ahead and simulate it. And here we go. So let's check this out. I got to bring the truth table over here, and let's make sure that I have the right values. I'm going to go ahead and group these and see if everything works. So I go combine signals. We'll call it ABC. Good. And then I'm going to delete these to get them out of the way. Okay, so I got 1, 1, 0, 0. Hey, 1, 1, 0, 1. We did it. It worked. This is fantastic. Let me change this radix to unsigned. So I have row 0 is a 1, row 1 is a 1, row 4 is a 1, row 5 is a 1, and row 7 is a 1. Then simulation starts over. We have done it. We have designed this truth table using structural VHDL, meaning that system H doesn't have functionality in it. It just instantiates lower level functionalities. So we built 3 lower level designs, inverter 1 and 3 and OR 5. We instantiated them in system H as components, and then we wired them up. Alright, that's it. So let's go ahead and end the simulation. So I'm going to end simulation, and then I'm going to end my project. I'm going to close my project, so I got to close all my files. 1, 2, 3, 4. I go to my project tab, and I go close project, and I am done.